Hello there. Welcome to Burn to Learn. Today we will be learning about the most popular topic called Arduino. In this video we will go through the basics of Arduino. So, what is Arduino? It is an open source prototyping platform, or say, easy to use circuit board consisting of a series of Atmega AVR microcontroller IC. These microcontrollers are made by the American company called Atmel Corporation. Arduino was born at the Interaction Design Institute, Ivrea, as an easy tool for fast prototyping aimed at students without a background in electronics and programming. And now it is developed and sold by the Italian company called Arduino. As they have open sourced the hardware designs, there are lots of other companies making these circuit boards nowadays. Though functionally they are the same thing, but they can't just call them Arduino. There are numerous third-party companies which makes their own variants of Arduino hardware designs. Arduino boards can read inputs like light on sensor, voltage, temperature change, etc. and turn into an output such as activate a motor, turning on an LED, publishing something on the internet. We can tell Arduino boards what to do just by sending a set of instructions to the microcontroller on the board. In order to do that, we use the Arduino programming language and the Arduino IDE software, which is also called Arduino Interactive Development Environment. So, why only Arduino? For physical computing, there are many other microcontrollers and microcontroller platform available, like Fidget's, NetMedia's BX24, Parallax Basic Stamp, MIT's Handyboard, and many others that offer similar functionality. All of these tools take the messy detail of microcontroller programming and wrap it up in an easy-to-use package. Arduino also does the same, but it offers some additional advantage for teachers, students, and interested amateurs over these other systems. Let's talk about those advantages offered by Arduino. Number 1. It is relatively cheaper compared to other microcontroller platforms. The least expensive version of the Arduino module can be assembled by hand, and even the pre-assembled Arduino modules cost less than $50. Number 2. As most microcontroller systems are limited to Windows only, the Arduino software IDE runs on Windows, Mac, and Linux operating systems as well. Number 3. Its simple, clear programming environment. The Arduino software IDE is easy to use for beginners and yet flexible enough for advanced users to take advantage of as well. Number 4. Its open source and extensible software and hardware. The Arduino software is published as open source tools, available for extension by experienced programmers. The plans of the Arduino boards are published under a Creative Commons license, so experienced circuit designers can make their own version of module, extending it and improving it. As mentioned earlier, they are doing that. Even students can build the breadboard version of the module in order to understand how it works and save money. Lots of advantages, isn't it? Okay, let's move on to its types now. There are numerous types of Arduino built and can be used as per one's requirement based on their features, like Arduino UNO, Arduino UNO, Arduino Media, Arduino Nano, Arduino Genuino Mega 2560, Arduino Mega ADK, Arduino Leonardo, Arduino Genuino Micro, Arduino Explorer, Arduino Mini, Arduino Ethernet, and the list goes on. There are lots of them. I'm surely gonna make a separate video on the types of Arduino in detail, so don't forget to subscribe and click on the bell icon so you don't miss it. Okay, if anyone tells you that he made a project using Arduino, he must probably talking about the Arduino UNO, as UNO is the widely used Arduino board. Arduino Genuino boards are the microcontroller development platform that will be at the heart of our projects. Calling Arduino a microcontroller would be incorrect because besides series of microcontroller, there are other hardwares as well. When making a project, you will be building the circuits and interfaces for interaction and telling the microcontroller how to interface with other components. So let's get familiar about the anatomy of Arduino UNO. First comes the microcontroller itself, which is the heart of our board. UNO is Atmega 328P base board, which refers to its 32 KB of flash memory or programming space, which is used to store our sketches. Out of 32 KB, 0.5 KB is used for the bootloader, and remaining space is available for writing codes. And the last digit 8 refers that it's a 8-bit processor. And the P is for picopower. Picopower is the new class of microcontrollers, consuming lowest power both in standby and sleep mode. Apart from 32 KB of flash memory, this microcontroller has two additional pools of memory. They are 2 KB of static RAM. This is where Sketch creates and manipulates variables when it runs. 1 KB of EEPROM. This is memory space that programmers can use to store long-term information. Flash memory and EEPROM memory are non-volatile. The information persists after the power is turned off. Static RAM is volatile and will be lost when the power is cycled. Crystal resonator. This controls how fast the microcontroller runs. Powering up Arduino can be done through the USB cable or via DC 9V barrel jack separately. It can accept voltages between 7 to 12 volts. The built-in voltage regulator reduces the voltage to 5 volts. USB port used for powering our Arduino UNO, uploading our sketches to the microcontroller, and for communicating with your Arduino sketch as well. This is possible because of another small microcontroller which acts as a bridge between our computer and main microcontroller. This is the chip which passes on the messages from our PC to Arduino and vice versa via connected USB. Microcontroller has a built-in bootloader which helps us to simply upload new program to the Arduino board, which eliminates the hassle of requiring traditional external hardware programmer. Analog pins A0 to A5. Analog pins reads continuous voltages from 0 to 5 volt, but not the current, as it has very high internal resistance, which allows very small amount of current to flow. They can also be used for digital inputs and outputs. Digital pins 2 to 13 can be used as digital input or output pins. We can see some of the pins, that is 3, 5, 6 and 9, 10, 11 with the tilde symbols. These can be used as analog output pin. Pins with tilde symbols can be used to output PWM square waves, that is pulse width modulation square waves. Internally, Arduino interprets the analog voltages with 10-bit numbers. That is, 0 to 5 volts will be interpreted as 0 to 1023. Conversion for standard 5 volt analog references can be seen in this chart. RC low-pass filter must be used to convert square waves into a continuous analog voltage. Pin 13 LED, the only actuator built into your board. Besides being a handy target for your first blink sketch, this LED is very useful for debugging. Power LED indicates that your board is receiving power. It's useful for debugging as well. Power pins section. 5 volt and 3.3 volt pins. They provide regulated 5 and 3.3 volts to power external components or circuits. Ground pin. In Arduino UNO pinout, you can find 5 ground pins, which are all interconnected. Reset pin is used if we need to reset the Arduino externally. IO-REF pin. This pin is the input-output reference. It provides the voltage reference with which the microcontroller operates. Input voltage pin. This pin is used to power the Arduino UNO board using an external power source. The voltage should be within the range of 7 to 12 volts. ICSP headers. ICSP stands for In-Circuit Serial Programming. Arduino UNO board has two ICSP headers, one for Atmega 328P chip and other for Atmega 16U2 chip. These pins enable the user to program Arduino's board's firmware or bootloader. Each of 6 ICSP pins in 2 rows 3 columns orientation available on the Arduino board can be connected to a programmer device via a programming cable or say IDE cable to be more specific. GX and RX LEDs. These LEDs indicate communication between our Arduino UNO and our computer. Expect them to flicker rapidly during sketch upload as well as during serial communication. This can also come handy while debugging. Reset button resets the Atmega microcontroller. You are surely going to use this a lot. Now, as we have known the hardware parts, let's jump onto its software part. As mentioned earlier, the Arduino software IDE is the one which allows us to write programs which they call sketches and upload them to our board. The Arduino Integrated Development Environment or Arduino Software IDE contains a text editor for writing code, a message area, a text console, a toolbar with buttons for common functions, and series of menus. It connects to the Arduino hardware to upload programs and communicate with them. We will see how to download and install Arduino Software IDE and details about its user interface in the next video. Hope you won't miss that. Besides the knowledge about the Arduino hardware and software, we must also know about the other things which we definitely require while making a project. They are sensor modules and Arduino shields. Before moving on to that, I want to request you to hit the like button if you like this video. Trust me, it motivates a lot to make more videos like this. All the input devices which outputs changes according to the given property of the surrounding environment can be called as the sensors, usually an analog voltage. This change might be anything from the change in the temperature, or humidity, or electromagnetic charge. Sensors are incredibly useful devices. Arduino boards senses the environment by receiving inputs from such sensors and affects their surroundings by controlling lights, motors, and other actuators. There's a lot of sensors available in the online market, or if luck favors, even in our nearest electronics stores. Temperature sensors like DS22 or 11, AM2320, DS18B20, etc. Range sensors like ultrasonic sensors, LIDAR, IR LED, etc. are commonly used. Arduino shields are the circuit boards, which are the plugins to the Arduino board to provide them additional functionalities. Like, if we are working on Wi-Fi related projects, then ESP8266 Wi-Fi shields can be used, or if we want to connect our Arduino with GSM network to send or receive messages, or to originate a call, then GSM GPRS shields can be used. These shields can be easily snapped onto the Arduino boards like a stack, but to do that, we must first ensure that shield pins are compatible with our development board. If a shield was designed for one type of board, the pin orientation might be according to that. For example, the Zigbee shield was designed for the Arduino UNO R3. If we want to use the Arduino Leonardo or the Arduino Mega 2560 with Zigbee shield, then we would need to reroute the connection and redefine the pin definitions. If you want me to make a video on sensor and shield types and their uses, do comment below and let me know. That's all for the Arduino basics. Don't miss the next part of Arduino series where we will learn how to install and use Arduino Software IDE. Thanks for watching and keep learning.